modern automobile is a very complex machine. Engineers are responsible for making all the separate components work together properly. Cars are just one area in which mechanical, electrical, chemical, civil, and other engineering disciplines are applied.
We sometimes take for granted the complex engineering involved in the everyday components of an automobile. Ever wondered how a compact disc player works?
No.
Well, we're going to tell you anyway.
Sound waves can be represented as voltage signals. These signals can be stored as the magnetism of a tape or the digital points on a CD. Binary data is stored on the bottom of the CD, with zeros as pits on the surface that are smaller than a human hair. Here we represent the signal with 3 bits. However, it actually takes 16 of these bits to represent 1 voltage point. A laser reads hundreds or thousands of these points every second. Because the laser scans this data at a constant rate, the CD has to rotate at a varying speed, starting from 500 revolutions per minute on the inside of the CD and ending at 200 RPMs on the outside. Voltage signals are then fed into a coil which is inside of a circular magnet. The coil produces a second magnetic field. The forces between the 2 magnetic fields cause the cone to vibrate, moving air and producing sound. Of course, the sound needs to be amplified, and there could be interference from the bumps in the road or the steel in your car. Controls engineers, both electrical and mechanical, continue to address these problems.
The CD player, like every other car system, needs a source of power.
There have been a lot of changes in the automobile in the past 80 years. However, its main power source, the internal combustion engine, has essentially remained the same.
The engine is a giant chemical reaction requiring oxygen from air and gas. There is typically a surplus of air to ensure that all the gas gets burned in a combustion chamber.
It's all part of the motion of heat, thermodynamics.
What you see here is a single piston in a 4-stroke engine. A typical car will have 4 to 8 of these chambers. First, the piston moves down, drawing in a mixture of air and gas. Then, the mixture gets compressed as the piston moves up. In a gasoline engine, the spark ignites the gases, causing an explosion which pushes the piston down. This is called the power stroke. The exhaust gases are expelled when the piston moves back up again, and this 4-step cycle repeats itself, typically 50 times a second or more.
Chemical and mechanical engineers work on internal combustion engines with anywhere from 1 cylinder in a lawnmower to 4 or 8 in a car. There are also larger internal combustion engines found in ships and locomotives.
There is selection of materials for engine parts, thermodynamics of the power cycle, lubrication of moving parts, and of course the effect on and by the environment.
The environment poses several hazards to the car. Corrosion can occur from the salt on de-iced roads in the north or from beach sand. Washing your car after a day on the beach can help reduce this onset of rust.
But automobiles do their own damage to the environment. Every year they spew out tons of toxic pollution, despite the use of computer-controlled systems to minimize these harmful emissions.
Some of these harmful particles, carbon monoxide and nitric oxides, are pollutants because they tend to combine with the oxygen we breathe, or worse, prevent our bodies from being able to absorb oxygen.
Several developments have been made to reduce pollution over the last 20 years. Catalytic converters break down harmful molecules into carbon dioxide and water vapor.
Harmful unburned gases can escape from the combustion chamber and accumulate in the crankcase. The positive crankcase ventilation valve is part of a system that diverts these fumes back into the combustion chamber, while preventing them from returning from the same route. Before, these gases were just expelled into the atmosphere.
Environmental laws, tough legislation, and consumer demands are requiring engineers to design practical electric vehicles and natural gas cars.
However, people want other things too.
Engineers from mechanical to civil to environmental are working to balance these demands from society to produce a more environmentally friendly vehicle with quick acceleration, long range and a tank of gas, low cost, and of course accessories like air conditioning.
The emissions from your car can be minimized thanks to computer controls in today's cars.
Like the ones in your car, all computers must withstand the high temperatures due to heat generated from the circuits. Mechanical and electrical engineers work together to ensure that adequate cooling of the CPU is available using the principles of heat transfer. For example, this case is designed to regulate airflow through the system. As a result, you normally get better cooling with the case attached than with the internals exposed.
Computers and electronics are carefully designed for each application, from the everyday VCRs, microwaves, and calculators to PCs and supercomputers. Computer engineers can determine which hardware and software are best for a particular application, be it tax accounting, accurate payroll, organizing a rock concert. The list is endless. That's no easy task in an industry where new computers are constantly becoming obsolete. And if the needed hardware or software doesn't exist, the computer engineer will develop it.
One of these new applications has been solid modeling, the representation of real-life parts on computer for analysis. This odd-looking part, called a cam, is rotating at a constant velocity and turning a portion of a road sign with 3 advertisements, one on each face of the triangle. This is a finite element analysis. The critical areas of stress are represented by the red and orange colors. All this gives the engineer a better idea of how the part will behave in the field. It's easier to correct the problem on the computer than to have the part break in operation. Solid modeling and finite element analysis are particularly useful for analyzing difficult geometries, like the cam, among other things.
What we see in real life begins with a sketch, a schematic, or a model. One of the most important tasks of the engineer is to make analytical models of real-life situations and objects. After all, we'd like to know ahead of time if what we build will perform the way we expect it to.
Civil engineers are responsible for the design of buildings, bridges, and highways. These structures need to stand up to wind, temperature changes, and large moving loads caused by highway traffic.
For example, many bridges use expansion joints since a bridge can expand or contract several inches due to temperature variations. Without these joints, the bridge could fail from the additional stresses. Civil engineers use principles of physics and mathematics to design these structures. Many of their equations, and a number of mechanical engineering equations for that matter, trace their origin to Newton's second law: force equals mass times acceleration.
If there's one thing all engineering disciplines have in common, it's the toolbox of equations that you learn in your college coursework that are applied in the field. If you'd like to learn more about engineering, you can read The Way Things Work by David Macaulay, or check it out at your local library.
Welcome to the remote presentation, a college education in engineering brought to you by the local chapters of the American Society of Mechanical Engineers and the Society of Women Engineers at Texas A&M. We would like to acknowledge Mrs. Hazelton, physics teacher at Bryan High, Dr. Griffin, undergraduate advisor at Texas A&M, and the National Society of Black Engineers for their contributions to this presentation. Engineers design, build, and improve most of the products you see every day. An increasing shortage of engineers means that the opportunity is ripe for a career in engineering. Unlike most majors, there are several good jobs available with a bachelor's degree in engineering. However, you will need a strong background in math and science to succeed in engineering. This is a comparison of starting salaries in thousands of dollars per year before taxes for engineering, science, business, education, agriculture, and life sciences, and liberal arts such as English or history. Of the majors listed here, only business and education can compete with engineering when it comes to the number of jobs available. But even then, engineers get the higher starting salaries. Here are some of the wide range of engineering disciplines along with the course that is fundamental in each discipline. Chemical engineers work with pharmaceuticals, food, and the polymers and plastics found in clothing and most everyday items. Petroleum engineers are concerned with the geology in an oil reservoir, refining the crude oil, and exploration. Electrical engineers work with computer hardware, electronic equipment, such as in your radio, your television, or microwave, and with such mediums as fiber optic cables. Industrial engineers make the day-to-day operation of manufacturing plant cost-effective, from minimizing the number of rejected parts or quality control to just-in-time manufacturing, ensuring that just enough raw material is in the plant at a given time. Mechanical engineers work in a wide array of areas, from the systems in a car, such as the transmission, the radiator, and the air conditioning, to superconducting materials and robotic controls. Civil engineers work with such structures as bridges, houses, skyscrapers, and highways. The aerospace engineer works with composite materials and structures for aircraft, as well as wind test models in airflow. The computer engineer will customize the software and hardware for each client's needs. If the needed equipment or software package isn't available, these guys will just design it. Some other engineering fields include agricultural, bioengineering, nuclear, environmental, ocean, and computer science. A typical engineering degree can take 5 years to complete, but credit by exam can help reduce this. Whether by advanced placement tests, CLEP tests, or exams offered by a particular university, testing out of these courses is cheaper than having to take them. However, if the course happens to be fundamental to your major, physics for mechanicals, chemistry 2, or organic chemistry for chemicals, you should consider just taking the class. There's a whole range of courses, math, English, history, just to name a few, for which you can get college credit while in high school. Having computer literacy will help you in college. While C and Pascal are most useful, once you've learned any language, even BASIC or Fortran, other computer languages are much easier to pick up. It's also a good idea to learn a spreadsheet program, whether for balancing a checkbook or printing some data, and a word processor before college. As a freshman, you will need some kind of word processor and possibly a spreadsheet in your coursework. Now, there's no doubt that a graphing calculator in a computer can be of great help to the engineering student, but these can probably wait until the beginning of the junior year. Many freshman courses even forbid the use of fancy calculators on exams. Also, when you buy a computer, it's important that it be able to expand to your needs. Remember that the computer you buy must run not only the software you use today, but the engineering software you may eventually want to use. You may be considering taking some courses at a community college before transferring to a larger institution. The classes are smaller and the professor can both spend more time with you and not be involved in research. The cost is a major benefit. However, your grades will not transfer, and you need a good grade point ratio to transfer. But most important of all, transferring your credits to another university can be a major problem. It's a good idea to get a listing of the courses that will transfer in writing, so you don't end up wasting credit hours. You may have to show the advisor in your department tests and a syllabus from the course to get credit for it. Remember to plan ahead and get it in writing. It is to your advantage to take some courses in physics, chemistry, and calculus during high school. These courses aren't as difficult as the college courses, but they do give you some exposure to what you will face as an engineering student. If you have an aptitude for any of these courses, you should consider becoming an engineer because these courses are the foundation for your engineering work. Here are some basic examples of how these courses relate to engineering. Here's an example of calculating the forces on a dam caused by the pressure from the water. You can see the influence of the weight of the water in the density term, rho, as well as gravity and the depth of the water. The height of the water on both sides of the dam is important too. The given equations calculate the force on a particular spot on the dam shown by the x. In real life, forces over the entire dam need to be considered, as well as potential difficulties with the soil below the dam. Combustion is one of the principal sources of power in the world, and it is all based on a simple equation. Oxygen from air and octane from gas yield a set amount of carbon dioxide and water vapor, in theory. However, engineers need to add additional oxygen to make sure all the fuel gets burned, and the high engine temperatures create harmful byproducts like nitric oxides and carbon monoxide. One reason combustion is so important is that it needs no catalyst to be fast. But the catalytic converter in your car uses these to help reduce pollution. Needless to say, you need the theory to understand what goes on in the engine. If you're not certain which engineering discipline to choose, you do have some time to make up your mind. However, after about 2 to 4 semesters, you will lose credit hours and delay your graduation if you change majors. Some majors transfer with minimal loss late in the junior year, such as aerospace to mechanical. GPA requirements and department space may also limit your choices, particularly with admission into your upper-level courses. However long you wait to commit, remember that if you can complete 3 semesters of engineering courses, the odds are that you will graduate in engineering. There is help to get through the first semesters. Talk to your professor or the teaching assistant. There usually is help from the department offering the course or from the department in your major. And even if you are not a minority, you may find useful information at the minority office. A word of caution about tutoring, however. Cram session can take as much trouble as actually learning the material, and it can only hurt you later. Don't expect to be stuck in a corner. You will have to work with others in a group project throughout your career and in school, testing and improving your communication skills. Also, engineers from different disciplines work together in engineering, and you will share coursework with students from other disciplines. One important lesson from working with others is that one person can't know or do everything. Remember to work not only with other engineers, but with technicians and specialists, from machine operators to accountants. These people have the experience you need to do your job well. Here are some starting salaries for engineering graduates. Chemical and petroleum engineers earn the most money, but mechanical, chemical, and petroleum engineers within the petroleum industry earn equal pay. Civil engineers typically work for the government, hence the lower salaries, while fierce competition among aerospace majors limits their salaries. This graph shows the number of engineers in the workforce and the expected shortage by the year 2000. The large number of electrical engineers can serve the computer industry, while the large number of mechanicals serve in a very broad range of industries. This graph compares annual salary over several years for advanced degrees. While engineering salaries are good with a bachelor's degree, they are even higher for advanced degrees. The catch is that you are not earning your salary while pursuing your advanced degree, so it takes 17 years for a master's student to make up that difference in salary. However, people with an advanced degree are more likely to be in senior management. It's hard to put a price on opportunity. Here are some typical engineering employers making airplanes, cars, military hardware, gasoline, plastics, electronics, and of course potato chips. Engineers also work to provide your telephone service and power. They even help make existing companies more efficient. Several government and research facilities also employ engineers, from the building and repair of highways to investigating pollution to exploring space and future technologies. Engineers serve us all. Thank you, and we hope you've enjoyed our presentation.
I'd like to take this opportunity to thank Dr. Tom Kozik for narrating this presentation.